Miss Chen, are you talking? We can't hear you.
Hello, can you hear me now?
Yes.
Okay. Sorry, I mute myself. We start now. We start now. Basically, same question, same assumption. It's an area bounded by curves. Now here, this area bounded by the sine curve, the straight line y equal x and x equal pi over 2, the bounded region, revolves about the x-axis, so the 3D figure can be obtained. Now I use the example from the textbook because you can see an illustration of this figure. Now it's not, I think something has changed because when you get this 3D figure and it's not a solid, I mean, it is a solid, but it's kind of like a container. It has a hollow part in the middle. In this case, this cone in the middle is hollow. But we're still using the same method. It's not big. It's not like, oh, this shape is different, so we use a different. But we still use the same method. That I will cut this 3D shape into pieces. I'm cutting against the x-axis. Now you can see that each piece, right now it looks like a strip, but it's not a strip. It's actually a, if I draw it, it's actually a ring like this. In the past, when we didn't get the hollow solid, then each piece is a disk. Now, when we get the hollow part in the middle, so each piece is a ring. However, we're still writing the same thing. In this case, this part, this little piece is dv. That is equal to pi r square minus r square times the thickness, which is dx. Now, the thickness is still dx. Okay, but we're not using pi r square dx. We're doing pi r square minus r square because it's a bigger circle minus the smaller circle. So that's the ring area, the area of the ring. And we also need to figure out what's the bigger r, what's the smaller r. In this case, the bigger r is the green, the distance from the green curve, that's the bigger r. And the small r is the distance from the orange curve to the x-axis. So now I can write dv equal pi r squared. The first r is the green r, so it's 2 sine x squared, minus the small r, which is the orange, that is x squared dx. Okay, now, so the required volume in this question is to add all the pieces. And also starting from the very left, this is the first piece. The first piece is very small, and this is the last piece. So the first piece is when x equals 0. The last piece is when x equal pi over 2. And then we simplify and integrate. To simplify, you need to take out pi. And then you have 4 sine x squared minus x squared. And then you need to simplify again. For this one, you need to use double angle formula. So it's 2 times, so it's not 2, it's 4, huh? 4 times 1 minus cosine 2x divided by 2. And then you can take out, it's not take out, it's pi. It's pi from 0 to pi over 2. And this one is 2 minus 2 cosine 2x minus x squared, close bracket, dx. And then you will get the integral, which is 2x minus sine 2x minus 1 over 3 x cubed. The value is from 0 to pi over 2. I want to make this very clear. It's correct. 2 minus 2 cosine and sine, yes. And then I put the value in pi. 2 times pi over 2 minus sine pi, which is 0. And then minus 1 over 3 times pi over 2 cubed. Minus 0. The second substitution is 0. So the answer is pi and pi minus 24 pi cubed. And the answer is pi squared minus pi to the power 4 over 24. And then it's done. Is it fine? Classwork. Classwork. In the classwork, now you don't have the illustration yourself from the textbook, so I'm going to draw this. So this line, I'm going to draw orange. And then a green line. Okay. A green line. Like that. And you see it's a 3D shape. So I'm going to draw 3D shape, just 2D. And then the cutting. Just this piece. Just this piece. This is a ring. Okay, this is a ring. So the bigger R, that's the bigger R, equal Y equal this. The smaller R from here, it's equal another Y, 4 minus x divided by 2. So each piece is dv equal pi r squared minus r squared dx. So the whole solid is from, it's pi, and all of that. Root This is the first r minus the smaller r. Dx. And from the left piece, now here the left piece is a huge circle. That's the left piece, and the right piece is a very small one. So the left one is 0, and the right hand side is 4. Okay. And then simplify. One moment. One moment. This is equal to pi 0 to 4, 4 minus x minus 4, 16 minus 8x plus x squared dx. Check if I'm correct. Okay. And then this is pi 4 minus x minus 4 plus 2x minus 1 over 4x squared dx. Make sure the signs are fine. And then pi 0 to 4. This is negative 1 over 4x squared plus x dx. And then it's pi from 0 to 4. Oh no, integration. So this one is negative 1 over 12x cubed plus 1 over 2x squared from 0 to 4. And then that will be negative 1 over 12 times 64 plus 1 over 2 times 16. Okay. And that will be something. 8 pi over 3. Is that okay? Now stop me if you have any question. Example 16. Refer to the figure. This is the bounded area by a curve. That's a parabola and a line and the two positive axes. And this is positive y-axis. This is x-axis. It's very small, but you must still see them. Okay. And this region is revolved about the y-axis. Now imagine the shape. Imagine the shape. I'm going to draw a 2D representation first. Then this is the 2D representation. Okay, now the textbook gives you the illustration of the 3D figure. Now, so you can imagine what it looks like. And what you should notice is that at the bottom, this part, this region, this region generated by this blue region, this part is not hollow, and this part is hollow. So this is a container, this part is hollow, and then the bottom, this part is not hollow. You know what I mean? Therefore, we need to do it two parts. This part at the bottom, you just integrate using disk method. This part at the top, you use the ring method. It's essentially the same, but anyway. Now, because we need to do it two parts, I need to know what this value is. So step one, substitution. Substitute x equals 0 into the straight line. We have y equal 1. So b can be found. Also, I need to substitute x equal y minus 1 into the parabola, and that is y minus 1 equal 4y squared plus 8. So 4y squared minus y plus 9 equals 0. That means that means 49. What's 49? 49 is 4y plus 8, 49. 3. Huh? What's the value of y? 49. X equal y minus 1 square. What am I doing? Square. No solution if there's no square. And then 3y squared plus 2y plus 7 equals 0. Eh? 2y. 3y plus 7. Huh? Not 4. There's no square on the right side. Must be crazy, huh? Sorry about that. That's y squared minus 6y minus 7 equals 0. And y minus 7, y plus 1 equals 0. I have two values, but I will keep the positive one. Now there are two values because there are two intersections, but I only care about the positive one, a. So a must be something negative 1. In this case, it's negative something negative 1. Not negative, something 7. 7. Okay, so this one is 6, 7, and this point is 0, 1. Now the cutting, now the cutting. Now from here, it's a disk. Now this part is a disk, so the volume equal pi r square. Pi r square. In this case, it's x squared dy. But from 0 to 1. This is from the bottom, from here. This is the first one, and this is the last one. So I'm saying from 0 to 1. And then the next part, when the cutting is this way, it's a ring. This part is pi. Let me write pi outside. That's pi r square. The bigger r is the green one. That's x squared minus the orange x squared dy. Now here, obviously, I can't use x squared. I'm gonna name this one x1 and this one x2. Now this is x2, this is x1. So x1 squared minus x2 squared. The green minus the orange. And then from 1 to 7. From 1 to 7. This is because the highest piece, that's the highest piece. 7. And then put everything in, take out pi. This one is x, and that is the green one. So x1, the green one. X1 squared equal 4y plus 8. This one is 4y plus 8. That's x1 squared. X2 squared is y minus 1 squared. So that's the correct integral. Now here, the x1 squared is already given in square terms, but this one is not a squared. The x2 is x2 itself, so you need to square it, and this one you don't. And then simplify. I can take out 4, right? That's also a simplification. And this one I will need to expand. And then further simplify. For this one, I can actually, I really regret this now, but anyway. Because I took out 4 and then I have a fraction. Otherwise, I didn't have a fraction, but it's okay. I regret it now. But from 1 to 7, it's negative y squared plus 6y plus 7 dy. And then the substitution for this one. This one is negative 1 over 3 y cubed plus 3y squared plus 7y from 1 to 7. More calculation. 4 pi, that's 2 pi plus 8 pi. Plus pi, the first substitution, negative 1 over 3 times 7 cubed plus 7 times 49 plus 49 minus negative 1 over 3 plus 3 plus 7. Okay. And then you use the calculator to find out the answer. Do I have an answer? I hope so, huh? It's something. And then you get 82 pi. Now in this question, you just, sometimes this part is very small, but you must still notice that this is not the whole part that's hollow. It's some partial, solid, partial hollow. Stop me if you need. Fast burn. refer to the figure, the volume of the solid generated by revolving the region bounded by the curve, the lines, and the positive axis. Still, they're very small, but you must see these two, positive and positive. Okay, and then let's try to draw this figure. Okay, that's good. And then let me shade. Okay. Now this again is partial hollow and partial solid. Now I need all the points. I need the points here. This one is already done. This one is 0. This one is 0. This one I need. This one I need. Now this one I already know. This one I already know, so I don't need that one. This one is 10. This one is 0, but this one in the middle I don't. So I need to find it. Substitute x equals 0 into the curve. X equals 0 into the curve. So 0 equal to y minus 2, y equal 1. So this point is 1. This point is 1. Okay. We also, for this part, I need a change of subject because later on I'm going to use x squared. And right now it's written in 2x minus y equal 2, and that's not in the subject of x. So I need a subject of x. So this one is changed to x equal y plus 2 divided by 2. I need a subject of x. And then the volume of solid, the bottom is pi x squared. Pi x squared dy from 0 to 1. The top is pi, this part, this little ring, is the bigger R, which is the orange line. The orange line minus the green. This is the small r, this is the small r, this is the bigger r. This is the small r, this is the bigger r. So small r is this one, 2y minus 2. Now notice that this one doesn't have a square because this one is already squared. For the second curve is given to you as x squared. So there's no need to do square again. And this range, the limits are from 1 to 10. There you go, the calculation. Simplification. Definitely take out 4. 0, 1. Y plus 2 whole square dy. This one I figure it's easier this way. I figure it's easier if I do pi 0, 1, y plus 2 whole squared, and then take out 4 dy minus 2 pi. Sorry, I don't want to take out 2 again. Now, last time I took out 2 and then it created a problem. Now then pi 0 to 1 to y minus 2 dy. I think it's easier this way. Because in this way I don't have to do the expansion. Am I right? Yeah, I don't have to do the expansion because I can just do adding 2 here. And then that will be pi over 4 times 1 over 3 y plus 2 cubed from 0 to 1 plus pi over 4 times 1 over 3 y plus 2 cubed from 0 to 1, from 1 to 10. 1 to 10. This one also from 1 to 10. 1 to 10. And plus this one is pi y squared minus 2y from 1 to 10. Right? And then the substitution. Pi over 12. This one is 3 cubed minus 2 cubed plus pi over 12. 12 cubed minus 3 cubed plus pi 100 minus 20 minus 1 minus 2. Okay, so this is pi over 12 times 27 minus 8 plus 12 cubed. I don't know what 12 cubed is, but 12 cubed minus 27 plus pi 80 minus -1, that's +1. And then 27, delete. I think you in the end you get the answer. Do you? The answer is 187 pi divided by 3. Yeah, I think so. I believe that. Okay. Last example about the hollow shape. Example 17, a circle, the equation of a circle is given. A circle is rotated about the y-axis to generate a solid called a torus. A torus is in the shape of a donut. Okay, and then find the volume of the torus. Now let me try the illustration. Trying to draw. Right. This is just, of course, there are lines here, like this, but I'm not going to draw that. It's too messy. Okay, but imagine this is 3D shape. This is the 2D. I'm just looking at the cross section. Okay, and then I will need, because I'm cutting it into pieces. So this is one piece. This is one piece. And this piece is a ring. It's a ring. I will need the bottom and the top. This is the bottom piece. This is the top piece. And this is the middle. So the bottom and top I need. So that is why I will put x equal to, substitute x equal to into the equation. The reason I substitute x equal to is because these two points can be found by this intersection. Therefore, y squared equal 1. So y equal 1 or -1. That tells me that the bottom is -1 and the top is 1. Okay. And also, this is a huge ring. This is the ring. I don't know how to draw it, but imagine this is the ring. So I will need, this is the small r, and this is the bigger r. That this is the bigger r. Maybe I draw it this way. This is the bigger r this way on the right hand side. So I will need the bigger r and the smaller r. Now both the bigger r and the smaller r can be represented by the equation of the circle, but I need to tell the difference. This side is the smaller r. Look at that, this figure. This side is the smaller r. This side is the bigger r. So I need to figure out which one is the smaller one, which one is the bigger one. So there you go. Because x minus 2 squared plus y squared equal 1, I can find x by solving. Now this happened before. When I try to find x, I need to take the square root. And obviously I need to consider taking the positive root or the negative root. And here I take both. Because later on I will figure out that this one is 2 plus 1 minus y squared. This one is x equal 2 minus square root 1 minus y squared. And either one, both of them are useful. Now this side, to the left of this dotted line, now this dotted line is x equal 2. Now to the left of x equal 2, this line should be represented by this. This is the left. Oh, sorry, this one is the left. And this one is greater than 2. This one on the right hand side is greater than 2. Therefore, should be represented by this curve. This is the right hand side. So there are two x. One x is smaller than 2. One x is bigger than 2. And then from the solution, one solution is bigger than 2. One solution is smaller than 2. And then you can assign them to different halves of the circle. In this case, when I try to find the volume, it will equal pi r squared, which is the purple line, minus the green line. And from the bottom to the top, from -1 to 1. You get it? And then simplify. To simplify this, is very simple. You just do the expansion. That's 4 plus 4 root 1 minus y squared plus 1 minus y squared minus 4 minus 4 root plus 1 minus y squared. Okay, and then you can see the terms, leaving you 8 pi from -1 to 1 square root 1 minus y squared dy. Okay, that's simplified. After simplification, you need to do the integration, and this one can be solved by trigonometric substitution. So bear with me. Let y equal sine theta, where theta is from negative pi over 2 to pi over 2. When x equal negative 1, also when y equal negative 1, sine theta equal negative 1, theta equal negative 90 degrees, which is negative pi over 2. And when y equal 1, sine theta equal 1, theta equal positive 90 degrees, which is pi over 2. We also have the last one, that is dy equal cosine theta d theta. Okay. Now the substitution, a to pi, from negative pi over 2 to pi over 2. This one is 1 minus sine squared theta. And this one is cosine theta d theta. I think so, right? Not crazy? I hope not. And then that is equal to 8 pi from negative pi over 2 to pi over 2. And this one, because I don't want to explain again. Basically, it's because theta lies in quadrant 1 or 4, so this must take the positive cosine theta. So cosine theta squared d theta. That means 4 pi from pi over 2 to pi over 2. This one is 1 plus cosine 2 theta d theta. Okay. And then 4 pi, that's theta plus 1 over 2 sine 2 theta, close bracket, from pi over 2, from negative pi over 2 to pi over 2. Finally, the substitution, 4 pi, that's pi over 2 plus 1 over 2 sine pi, which is 0, minus negative pi over 2 plus 1 over 2 sine negative pi, which is also 0. So that means 4 pi times pi. The answer is 4 pi squared. Now maybe you have forgot. When you see something like this, you need to use the trigonometric substitution. Is that okay? Now, this is the very typical question where you must figure out the curves, the equation of the curves yourself. It's not entirely given. It's given by one equation, and you must solve the equation of the two halves by yourself. Last work. The figure shows the shader region bounded by the quadratic curve and the x-axis. Find the volume generated by revolving the shader region about the y-axis. Let me try draw. Let me try draw the shape. plus freehand. Freehand. This is a 3D figure. For the integration, I must do from the bottom to the top. So the bottom is 0 and the top must be found. So that's why my first step is to find the vertex. The vertex is 4, 4. Therefore, the bottom is 0 and the top is 4. Okay. Now each piece is hollow, or each piece is hollow in this case. However, we have a smaller r, which is a smaller x, and a bigger x. Now both x's are from this quadratic function. We just need to find out. So from this, we know that, maybe not so quickly, but slowly you will know that x minus 4 whole square is equal 4 minus y. So that's why x minus 4 is equal to plus or minus 4 minus y. And then I have 4 plus root 4 minus y. And the other one is 4 minus root 4 minus y. The two different curves. Okay, you don't have to write all the steps, but the result must be shown. And then you need to assign which one is which. Now, obviously, you have a 4 plus and a 4 minus. And then we also know that this line is x equal 4. This line is x equal 4. So the left one, obviously, should be the smaller one. That is x minus, oh, sorry, it's not x minus, 4 minus. 4 minus. And this one must be the bigger one. That's 4 plus. That's how you distinguish. Okay. Now, the volume. The volume is pi. R, the bigger R is the bigger one, minus the smaller one, dy. From the bottom, which is 0 to the top. That's it. That's it. And then you simplify. Now you can also simplify by factorizing because this is 4 plus multiply 4 plus minus 4 plus. Factorizing can also help you simplify. In the end, again, it's 8 pi from 0 to 4, 4 minus y dy. Now this one, you don't have to do the trigonometry substitution. You just need to do this, negative 8 pi. Just need to do multiply negative 1. And then the integration. And then zero minus 4 to the power 3 over 2. And then it's 16 pi over 3 times 8. Right? 128 pi over 3. Huh? Why is it? Eight. That's 8. From 0 to 4. 16. Oh, yeah. Thank you. Cassandra knows. From here it's 16. 16. From the third row, it should be 16. Now this is 8, but this is 2. So 8 times 2, that's 16. Okay? That's all, huh? That's all. Now 1 minute break. Okay? Okay, let's continue. The last part. The last part is a huge, I think it's a huge leap because this time we're not revolving about the x-axis. You see the title is the solids of revolution about a line parallel to the coordinate axis. Typical example 18, is that this shape is revolving around about y equals 3. Let's read it. The figure shows that the curve y equal 2 cosine x plus 2 and between 0 to pi over 2. This is 0. This is 0. This is 2 pi. From 0 to 2 pi. And the line y equals 3. That's the figure. Find the intersection. I'll just find the intersection first. 3 equal to cosine x plus 2. Cosine x equal 1 over 2. So x equal 60 degree, which is pi over 3. And the other one is 300 degree, which is pi over 3. Therefore, the intersections of pi over 3 comma 3 and 5 pi over 3 comma 3. Right? No problem, because I'm only looking for the solutions within 0 to 2 pi. So this one is pi over 3 plus 5 pi over 3. Okay. Now the volume of solid generated by revolving the region bounded by the curve and the line about the y equals 3. So that is the shape. So this is the illustration of this shape. Okay, so because of the axis is changed, I guess it's not the same thing. It's not the same solid. So how do I calculate? We will use, so I will cut this into pieces. And then I will take a piece, find dv. dv equal pi r square dx. So this little piece is pi r square dx. And here, pi is still pi. R is not y. No, R is this. This is R. This is R. So from the graph, we can see that R is equal to 3 minus y. Now I'm using the purple line minus the green line is because the purple line is higher and the green line is lower. Okay. Now if you use the green line minus purple line, then that will be negative. Now you want R to be positive. Anyway, that means this is 3 minus 2 cosine x plus 2 close bracket dx. Now dx is still dx because this is dx. And that's it. That's it. So I think it looks like a huge change, but actually it's not. It's just pi, still pi r squared dx. It's just r is changed. R is changed to 3 minus 2 cosine x plus 2. And then from the left piece, this is the left to the right. Left is pi over 3. The right hand side is 5 pi over 3. Simplify. This is 1 minus 2 cosine x squared dx. Further simplify. 1 minus 4 cosine x plus 4 cosine x squared. Further simplify. 1 plus 4, 1 minus cosine x plus 2 bracket 1 plus cosine 2x close bracket dx. Further simplify. Become 3 minus 4 cosine x plus 2 cosine 2x dx. Now when it's this simplify, I will do the integration. Okay, and then the substitution. Three. This is negative root 3 over 2 plus sine 2x. And this one I'm not sure. Sine 10 pi over 3 equals sine 4 pi over 3 equal negative sine pi over 3. That's negative root 3 over 2. minus negative pi negative root 3 over 2 plus negative root 3 over 2. That is equal to pi 5 pi plus 2 root 3 minus root 3 over 2 plus pi minus 2 root 3 plus root 3 over 2. And then delete. That's not good. Plus 2. Okay. The signs sine 10 pi over 3 is sine 4 pi over 3. That is sine pi over 3. That's correct. That's plus. I think it's this one. This one is a problem. 4 sine negative. It's positive. Wow. Sine pi over 5 pi over 3. That is positive. That is positive. This one is sine Oh, yes. I don't know. Yes, it's all positive. I don't know why. It's all positive. Why is it negative? Then that is positive over 3. Right? Yeah. So here, this one is negative, positive, negative. Right? So yeah. That's pi 4 pi plus 3 root 3 close bracket. Oh, that's it. So it's a simple example, but the calculation is messy. Now, the only thing different, it's not the same, but it's just this need to be found. Now, in the past, you need to find out as well. But in the past, it's always like something minus 0 because the axis is the coordinate axis. Right now, the axis is not. The axis is y equals 3. So you must find the distance from the curve to y equals 3. Practice. The region revolve around y equal 1. Now this part, is below, this part is above. But anyway. This is the shape. Okay, I don't need the bond. Do I need the boundary? I do. I do. Do I need? I don't, because I have the left piece, which is x equals 0, to the right piece, x equal 1, x equal 4. I think I'm just gonna integrate from 0 to 4. Okay. As to the piece, these are disks. Now each piece is a disk. Now each piece is pi r squared. Each piece is pi r squared dx. This one is also pi r squared dx. It's a slight variation though. Now, to the left, the radius is this length. Now, this is the radius. The radius is this length. You should use the purple line minus the green line, which is 1 minus, that's to the left, the radius. Now to the right, the radius is from the green line to the purple line. So right is r equal green line minus the purple line. Now, if you are calculating the area, obviously the left and the right, you should write it differently. However, since we're squaring r. Now, in the calculation of the small piece, it's not pi r dx, it's pi r squared dx. So although on the left, the r is 1 minus root x, on the right-hand side is root x minus 1. But since we're squaring it, they should equal. They should equal. That's why I'm not doing 2 pieces. I'm doing 1 piece, just 1 piece. It's pi r squared dx from the left to the right. Now, instead of you will need find 0 to something. This perhaps is, what is this? X equal 1, y equal 1. From the left is 1 minus. And from the right is 1, is root x minus 1. Now, if you write this, then that's, I think it's more difficult, isn't it? If you write this, that's obviously more consistent with the geometry. But since the outcome is the same, so I just write that. Just 1 piece. Okay. And then expansion. And then integration. Okay. Okay, and then substitution. And then the answer. I hope. I think so. I think so. Eight, 12 minus 12 minus 32 minus, I think so. 12 minus 32 over 3. Correct. Example 19. The region revolves about x equal -1. Find the value. Okay. Now, first of all, I know that these two numbers are here, but actually the question doesn't give you these two values. We need to show the steps of finding these two values. That is to substitute x equal -1 into x equal 3 minus y squared. I have that. So that's how these two values are found. The reason I need these two values is because I need to cut this into pieces. Now I'll cut this into pieces. This is one piece. And I need the bottom and the top. Now these two are my boundaries. I need these two values from -2 to 2. As to each piece, it's pi r squared dy. I'm cutting horizontally, so it's dy against the axis. So here, pi r squared, r must be defined. R must be found. And here, I'm sending this r is from the green to the purple. You see, this is from the green to the purple. So I'm using the green minus the purple. So you can see 3 minus y squared minus purple -1. Okay, so the volume equal pi from the green, that's the green. I'm using the value of x. The right hand side minus the green minus the purple. This is x minus -1, so minus -1. From the bottom to the top. Simplify. Right? I think so. Q. Also. And the answer. Yeah. Why this doesn't have 1/5? Wonder why. I don't have 15. Why do I not have 15? 1 minus 1 squared. Oh, squared. Missing squared. Erase this. Sorry, I thought so. Why is my answer? I left out squared. It's pi r squared dy. Sorry. So this one is actually 4 minus y squared dy. So it's a lot to deal with. 16 minus 8y squared plus y to the power 4. I wonder why I don't have 5. And then equal pi 16y minus 8 over 3 y cubed plus 1 over 5 y to the power 5 close bracket from -2 to 2. And then the substitution. 32 minus 8 over 3 times 8 plus 1 over 5 times 32 close bracket minus -32 plus 8 over 3 times 8 minus 1 over 5 times 32. And that will give you the answer. Now you have the calculator, you should be able to do it, okay? Don't miss out the square. Fast one. The volume of the solid generated by revolving the region bounded by the curve. The curve is given to you as subject of X. That's a good thing, huh? And then the line, the purple line, and the x-axis about the purple line. Draw. I always try to draw. Huh? So that's the shape. To integrate, I need the pieces. I also need the bottom and the top value. Therefore, oh, this is, I think I just, to save time, I just found this intersection. Oh, this is pop. So I know that I'm integrating from 0 to 1. Okay, so the volume of the solid is pi r square dy. Something square dy. Pi r square dy. Pi r square dy. And r in this case is this one. This is r. R in this case is from purple to green. So I'm using 5 over 2 minus 1 over 2 y cubed plus 2. That you use the purple minus green, not the green minus purple. No. It's the same if you use the green, because after squaring it's the same, but technically it's purple minus green, technically. So I'm putting in this part. 5 over 2 minus 1 over 2 y cubed minus 2 from bottom to the top. Simplifying. Not forgetting the square outside. And then take out 1 over 4. I think it's easier that way without a fraction. Still have to do the expansion. And then the integration. Okay. Luckily, the substitution is easy this one. Why is it? Let me look. What? Definitely from 0 to 1. And it's minus this. Why is the answer wrong, Ken? From the bottom to the top. And each piece is pi r square dy, no problem. 1 over 2 minus, no problem. Square, no problem. 6, no problem. 3, no problem. 1 over 4, no problem. 9 pi over 56. What is a 9 pi over 56? Pi r squared. Yes. Two y cubed should be 1 over 2y to the power 4. 2y cubed. What? The integration of 2y cubed. Oh. I don't know. I don't know what am I doing. Yes, it's 1 over 4 y4. That's not 1 over, it's 1 over 2, sorry. 1 over 2. 1 over 2. Oh. So 1 minus 1 over 2 plus 1 over 7. That's why. Oh. Okay, last example. Last example. At this time, this shape, which is away from the axis, y equal -1 is the axis. This shape is away from the axis, revolves about the axis, and the 3D figure is generated. In this case, can you imagine what the shape is? Please imagine what the shape is. Okay. Let me draw the other side. Okay. I drew it wrong. I should draw this one. Sorry. I should draw this one. And this one. Actually, the color does not matter. Okay. Now what I'm cutting. And I'm cutting this piece and this piece. It's a rain. And I not also need the boundary. I know this side is 0, so from 0 to this, I need this one as well, the boundary. Oh, I need a boundary. That's it. That's it. So step 1, solving y equal 8 minus x squared and y equal x squared. I have x squared equal 8 minus x squared to x squared equal 4, x equal 2 or negative 2. This one is rejected. Okay, so this one is 2, 4. So I'm integrating from 0 to 2. Okay. Now as to the ring, this is the smaller r. I'm still using pi r squared minus r squared. So this one is the smaller r. This one is the bigger r. The small r equal from the orange to the purple. The bigger r is from the green to the purple. Okay, therefore the volume equal pi r squared minus r squared dx from 0 to 2. Simplifying. Into the expansion. Do the expansion. Simplify more. Right? And then integrate. Now I would take the coefficient 20 out, but it's not necessary. Otherwise, I'll have a fraction. Last time I learned it. This will be negative 4x5 plus 8tx from 0 to 2. And that will be pi negative 4 times 32 plus 160. The substitution is so easy. That one is what? Why can't I get the correct answer today? What is against me? Oh, it's square, sorry. Made a mistake, it's square. (20/3x³). Oh, sorry. It's negative 20/3, 8 plus 160. Right? That must be correct now. Yes. 320 pi over 3. (320 pi over 3 is the answer. Okay. What is this? Class practice. In the figure, the straight line and the curve gamma, L and gamma, they intersect at pi, 2 comma pi, intersection. The x-intercept of L is 1. Find the equation of L. The equation of L is y minus 0 divided by x minus 1 equal pi minus 0, 2 minus 1. That means pi over x, y over x equal pi over 2, pi over 1, pi over 1. Sorry. So y equal pi x minus pi. That is pi x minus y minus pi equals 0. Equation of the straight line. Okay, now the volume is generated by revolving the region bounded by this, the axis, the green curve, and the straight line L. So I think a similar shape will be formed. Not a very good drawing, but I'll try. Okay. Do I need the boundary? I think I already have 0 to pi. So I don't need the boundary. Let's do each piece. This piece is pi r squared minus r squared dy. And the bigger R is from green to purple, the small r is from orange to purple. So I think I still need the orange line. That's why my first step is to change the orange line to a subject of x. Now, because the small r is the orange minus the purple. Okay, the greater R is the green minus the purple. So the volume. Sine y plus 2 minus 1 minus 1 from 0 to pi. Simplify. This is sine y plus 1 whole square minus y pi over y whole square. Expanding. Sine square plus 2 sine y plus 1 dy. This one will be 1 over pi y squared dy. So need to simplify. This one, I think I can actually do. Right? I hope I'm right. Don't want to be wrong. Horrible. Wrong. Ugh. Did I multiply y correctly? I think so. Did I square correctly? I think so. Simplify again. 3/2 minus 1/2 cosine 2y plus 2 sine y dy minus 1/pi times 1/3. Where did I have this part though? The answer doesn't have this part. There must be something wrong. Pi over y squared. It's definitely from 0 to pi. Yeah, it's from 0 to pi. What I'm thinking, it's from 0 to pi. Oh. uh, yeah. And then substitution from pi. 3/2 pi. That's 0. Cosine pi minus 0 minus 0 minus 2. Yeah. Equals 3/2 pi squared. Huh? What is 7/? What is a 7/6? Oh. I'm crazy. And then that's 7/6 pi squared plus 4 pi. Wow, I actually didn't make any mistake. It's correct. That's it. I hope you know that I recently updated the next test dates, which is on the 17th, I think. And one is on the 24th. Let me see.
Sorry, Ms. Chen, since most of us will be going to the biology field trip on the 24th of May, so we cannot do the revision test on that day.
24th or 17th?
24th.
th is the M2 test. And the revision test is on 24th. Now this test, the revision test does not count, so we'll find another day then. Okay.
Thank you, Ms. Chen.
For the 17th. still goes on. Okay, that's all. That's all. I hope you enjoyed calculus. The last bit. The last bit is kind of repetitive, but I don't know how your progress, what your progress is. Some can really manage. If you find it repetitive, that means you learned. If you find that's very confusing, sometimes dy, sometimes dx, sometimes from here to here, sometimes this way, you still need some help. And we still have time, luckily. So don't give up. Unless you have any question, you can go. Bye-bye.